It's not easy. It's dangerous. It hasn't been done before. But these are the sorts of things that capture people's imaginations. Let's talk about the future of space exploration. Now, if you know me, you know that I love space. Which is why I'm excited to be back on the set of Star Trek Continues. To kick off the next Innovation Spotlight. Today's topic, space exploration. Now, outer space is one of those topics that has captured mankind's imagination for decades. Let's meet someone who's turning that imagination into reality.
We have the technology now to go to Mars, so we can do it, and that's why we will do it.
Hey boss, I'm Grant.
Hey Grant,
Nice
welcome to my
meet
ship.
Thank you. We're here with Bas Lansdorp, CEO of Mars One, a non-profit organization based in the Netherlands that's seeking to develop a permanent human colony on Mars. So, can you tell me a little bit about the Mars One mission?
Mars One is a not-for-profit organization that's establishing the first human settlement on Mars in 2025. The very exciting thing about Mars One is that it's a mission of permanent settlement. So the people that we send to Mars, they're staying there. And instead of trying to bring people back, we send more people every 2 years. After 50 years, it might just be possible for there to be a self-sufficient colony.
You're having to develop a lot of these technologies that don't exist.
Well, what's very important to realize is that because it's a mission of permanent settlement, while the systems don't exist, the technologies do. We don't need bigger rockets to send the cargo or the humans. We don't need bigger landing systems. We don't need to invent the technology to take off from Mars. It's a lot of new system development, and certainly some improvements will be done, but it's not new inventions needed to get humans to Mars.
Yeah, sure. Why reinvent the wheel?
Well, Mars ain't no picnic. Don't DIY Mars.
Yeah, okay.
As long as you can make it really about exploration, you have to make it about humans, because humans care much less about robots than they care about humans, except maybe geeks like you and I.
Yeah, depends on the human, I would say.
As long as you keep the story interesting, people will be interested. That's stuff that you remember, it's stuff that inspires. And that's what Mars exploration can also bring.
All right, thank you.
Thanks.
All great ideas start in science fiction.
Hey John, come in John, can you hear me?
I can read you loud and clear, Grant.
Excellent. Hey everybody, this is John Thornton. He's the CEO of Astrobotic. So John, can you tell me a little bit about Astrobotic?
Sure, Astrobotic is a lunar logistics company. So we think of ourselves like a FedEx or UPS to the moon. We take packages from around the world, we bolt them up on our lander, which is our delivery truck, and we drop them off on destinations on the moon and on the surface. It's our goal to make the moon accessible to the world, and we're doing that by enabling access to the moon.
What do you think about colonizing the moon? I mean, do you see someday having a moon-based alpha?
Yeah, someday we do imagine that the moon could be colonized. What we're looking into right now on our first mission is a destination called Lacus Mortis. It translates to Lake of Death, but the reason that we go there is that there's a very unique feature called a skylight there. And it's thought that if you can get to the bottom of one of these skylights, that it could be an entrance to a cave. So if we can find a cave, we can use it for shelter for people, much like people settled here on Earth in caves first. We're starting to put together the pieces of what might be necessary for future human settlements even now. The cost to get to space is coming down dramatically. What used to cost $10,000 per pound today costs on order of $1,000 per pound. So one day we do think that will happen, and it might happen sooner than we think.
Awesome. Well, thanks a lot for your time, John.
Thank you, Grant. Signing off.
John, come in. John, do you read me?
Yeah, Grant, we read you loud and clear down here in Alabama.
Awesome. So everybody, this is John Horack from Teledyne Technologies. So John, Teledyne's been involved with NASA doing projects since the 50s, since the original space race. Can you tell me a few of the projects that you've worked on?
We've been involved with nearly every project since the beginning, and today we operate the payloads on board the International Space Station, and we're building hardware for NASA's new launch system.
What are some design considerations, some challenges that your engineers have in designing equipment that has to go into space?
There's a couple things that are very, very important. Number one is you have to design it for an extremely hostile environment that has to work in vacuum. It's got to work in the presence of radiation. It's got to work in the presence of extreme temperatures. But maybe more importantly than that, everything has to work together. Your thermal design, your electrical design, your mechanical design, your ability to withstand radiation, all of that has to work together. But the ultimate test is when it flies and you push the button and turn it on once it's in space.
So you put a person in a capsule. What ergonomic considerations do you have for your equipment?
Well, for example, you may need to use a switch. And it may be the case that the astronaut has to have a glove on when that switch is activated. And so, I mean, you can think about it. You're more dexterous if you can use your fingers, but you can't do that outside a spacecraft. So you have to think about things like that. When you're riding up the hill in the rocket, it's an incredibly vibrating environment. You're jostling all over the place. So if you need an astronaut to reach out and punch a button, that button better be pretty big because their hand may be bouncing all over the place.
All right, John, sorry, I gotta go right now because I have to meet another friend of mine. If only there was some way I could transport across the galaxy instantaneously. Oh, wait. Hey everybody, I'm here with my friend and space engineer, Babak Firdausi. You and your team landed a nuclear-powered, semi-autonomous robot that is equipped with a laser, on another planet. Yeah. How do you feel?
I feel great.
That's like science fiction, but in real life, man.
We are very fortunate to get to do some of the coolest things in the world today. Or not in the world, I guess, the case would be. One, it's a tremendous experience because I invested so much and I worked on that project for 9 years before landing. Many of the people on that team have been on there, 5, 10 years, whatever. I mean, historically, spacecraft have like a 50-50, percent chance of landing on the surface successfully. That's why during the landing, you see the kind of the raw emotion of like the joy and the tears and everything coming out at once because it's just like this, we did it. Like we raised our kid.
What technologies would need to be developed to make space exploration easier?
Generally speaking, I think energy storage is a real issue. Constantly limited by how big batteries you can carry, how you survive night times on Mars and other places. The great thing about space is there's an abundance of solar energy, so it's just how efficiently you can grab it.
Is there more that we can learn from going back to the moon?
There are missions, still at the moon right now that we're doing lunar reconnaissance orbiter, things like that are understanding the moon. But I think the more exciting part of the moon is really as this kind of the launch pad for other things, right? It's near Earth, it's a very reasonable place to get to, and it doesn't have the heavy gravity of Earth. So if you can get things there, it's a nice stable platform. You can build huge structures, the same kind of structures you see on Earth, but now without the atmosphere to deal with. I mean, I still have a dream of like a Hubble-like telescope on the surface of a moon. I would love like a week-long vacation on the moon. I think it's something special to see like an Earthrise. You know what I mean? Like just to take in the whole planet, like see your own whole planet at once.
See, that would be the ad right there.
Yeah.
For vacation on the moon.
I would
watch the Earthrise. Cool.
Yeah.
Thanks, man.
Thanks.
Welcome to the bridge. Here, take a seat.
This is the seat I want to be in.
That's the seat. Everybody, this is Glenn Smith. He's the CEO of Mouser Electronics. So let's talk about Mouser.
Okay.
Do you think Mouser will ever distribute parts on the surface of the moon?
Oh, I don't have any doubt about it. It fits our model perfectly. I mean, you're going to need small quantities and you're going to need them immediately, and that's what we do the best. So there's nobody else better suited for that environment than we are.
And you know what, I can imagine that if you have a colony on the surface of Mars, you're going to need parts that are cutting edge. You can't be using old parts.
You're absolutely right. I mean, you're going to need the technologies that may be invented while you're there.
Well, Glenn, do you want to see some more of the ship?
Are you kidding me? Of course. That's why I'm here.
Hey, this is Grant. I'm on my way. It's awesome to hear about all the exciting innovations in the field of space exploration. As always, Mouse is proud to offer the newest components and help empower that innovation together. Head on over to the Innovation Hub, where you can delve deeper into the subject of space exploration. We'd also like to thank our sponsors who helped make this episode possible: Microsemi, Vishay, and Phoenix Contact.